While we've looked at the basic concepts of these common graph functions, today we're going to look at how to transform these graphs, to shift them up, down, left, or right, shrink or stretch them, perhaps reflect them. Below, on your OneNote notebook, there is a link where you can go to a website called Desmos, and all the equations I'm going to work through are already in that graph. And then here I have set up a chart for you that will be linked in Canvas that you can print if you wish to fill out as you go. When you're performing the transformations of these graphs, one of the key things is you must start with the parent graph. And by that, I mean, we know that a squared graph, a quadratic, has a parabolic shape. We know which ones have an asymptotic element. We know what an absolute value graph looks like. And then we take those equations and we start with parentheses and we shift the graph left or right. We then deal with multiplication outside the parentheses, and that leads to a stretch or a compression. If it is an a value greater than 1, it stretches the graph vertically. And if a is less than 1, it compresses the graph. We then deal with negatives, which lead to reflection. If there is a negative inside the parentheses, then it's reflected across the y-axis. And if there's a negative in front of the parentheses, then it reflects across the x-axis. And finally, we deal with the addition and subtraction outside the parentheses, which leads to a vertical shift. So what does all of this mean? Well, let's look at this first graph. We see here that our a value is a positive 1 out front here. So we know our right hand's going to go up. And then we know our left hand is going to go down because the exponent is odd. What I'm referring to with Desmos is you can come over here and then you can check your graph. We see that that matches. But then what do we want to do is we want to deal with what's inside parentheses here. When it's inside parentheses, it shifts to the left or right, and we always do the opposite of what's in parentheses. So here we're going to take this point and we're going to shift it to the left 2, but then it's going to keep the same general shape. And again, if you go back to Desmos, you can click on that second graph there, and it does indeed shift to the left. What I would like you to do as you work through these is I have posted a key on OneNote below this initial blank page. We're going to work through a few of them together, and then I would like you to try a few on your own. So let's look at another one here. If we look at this absolute value graph, we know the general shape of absolute value. Inside parentheses is going to be a horizontal shift. It's the opposite, so we move over 4 to the right. As we continue down through these graphs, you're going to see in this case, we're dealing with an asymptote graph. A is positive, so we know that the right hand's going to be up. The exponent is a 1, which is odd, so the left hand will be opposite. And notice here, this is what I would call outside the function. If this was 1 over x plus 3, I would consider that inside the function. And from your notes above, you'll notice that outside the function causes a vertical shift. So this graph is going to move up 3 instead of right or left. And again, you can go to that Desmos page, and I can graph the original function, and then I can graph the second one and see that it does indeed move up 3. Again, all of these are posted on the key. Let's move down to one that has a multiplication factor. So for example, here, we know for this parent graph, we have a square root of x. So we know it's going to be the right hand up, and there's going to be no left hand because it's an even root. And that's our parent graph. But then as we look out front here, we're multiplying by 1 over 10, which is less than 1. And from our notes above, we know that that indicates that it's going to shrink vertically, and so it's going to look like this. Again, if we go over here to Desmos, I can jump down to where we have the absolute value of x, and then I can multiply it by 1/10 and see that it does indeed shrink vertically. The last one I want to look at together is one where several things are happening. So we're going to jump down to this graph here. This is our parent graph, which is a square root. We know what that looks like. That +1 is going to shift it horizontally 1 to the left. So that moves it over here. We then have to look out front at the 2, which is going to increase it vertically. So it's going to get steeper more quickly here. Then we have a negative. That negative out front, as I indicated in your notes, is going to reflect it across the x-axis. So suddenly this graph is going to come across the x-axis. The x-axis acts like a mirror from the original graph. And then last but not least, this +3 outside is going to shift it vertically. So this graph is now going to move up 3. Again, if we go back to Desmos, we can graph the original function, square root of x, move it to the left 1, vertically stretch it by a factor of 2, reflect it through the x-axis, and then move it vertically 3. Take some time to work through these on Desmos and let me know if you have questions.